All right, so this one is number 9. Given the functions, right, f of x and g of x, find f minus g, and then state its domain. So here's x minus g. Make sure to distribute, right? And then we have 4x, right, plus 2. That's it, and your domain is all real numbers. There's no restrictions there. So that was an easy one, but I had a question about that. All right, next, determine whether the graph is that of a function. If it is, use the graph to find its domain and range, intercepts, if any symmetry with respect to x, y axis or origin. All right, so basically, which one of these is true? It is a function, okay? And then what do we have to see? Domain. What is my domain? All real numbers. Okay? It's a parabola. All real numbers is my domain. So right away, this says my domain is x is less than 4, which is not true. So that one's out. D's out. So it's going to be one of these two. My range. They have the same range here. So the range is 4 and everything less. So y is less than or equal to 4. Okay, my intercepts, what are my intercepts? My intercepts are here, here, and here. Let me clear that out because I wrote all over it. Now you can't really see. Okay, my intercepts are here at -5, 0. Here, is that at -5? No, it's not. What am I talking about? That's at -3, 0. Sorry. -3, 0. Right, that's this. This one here is 1, 0. And then your y-intercept is here, which is at 0, 3. So which one of that is true? This one here, right? -3, 0, 1, 0, yeah. So here, okay? Okay, symmetry, none. It's not symmetric about the y-axis because it's not centered there, right? It's not on the y-axis. It's not symmetric about the x-axis either, and it's not symmetric about the origin either, which would be the line here. So, neither. No symmetry. All right, for what number x is the function greater than 0? Where is the function? I'm sorry, less than 0. Less than 0. So, my function is less than 0 here. Right? All of that. So, all of my x's in here would make my function less than 0, right? So, for what numbers of x? What number is x? So that's from here, which is what? This is 20? Is this 20? Now I wrote all over. I can't even see what's going on. This is 20. 1, 2, 3, 4, 5. Yeah, so 4 each. 4 each, right? So that's 4. That's weird. 1, 2, 3. So this is 12, right? And this is 4, 8, 4, 16. So what's between 12 and 16? 14. It's a little bit weird that they made it in 4s, but whatever. So it's from, but less than, so 12 up to 14. Not included. I'm sorry, -12. -12 up to 14. All right, that's when the function is negative. What else we got? Determine algebraically whether the function is even, odd, or neither. So remember, you have to plug in f of -x and see what happens, right? If it's the same thing you started off with, it's even. If everything is opposite, that means both terms are the opposite sign, it's odd. And if it's neither, it's neither. So what do we got? 5 times -x cubed plus 2. What does that give me? This is going to be -5x cubed plus 2, which this is opposite, but this is not, so this is neither. Okay? Next up, the function is given here. Determine whether the function is increasing, decreasing, or constant on the given interval. The interval says from 0 to 1. So when x goes from 0 to 1, this piece right here, what is the graph doing? At 0, I'm up here. When it goes to 1, it's going down here. So we are decreasing. Okay? Those are your x's, your intervals of x there. All right, and then this one. A, find f of 0 and f of 6. So what is my function when x is 0? That's what that means. So when x is 0, my function is 0. So that's 0. F of 6, well, when x is 6, my function is 0. 0, 0 for this one, right? F of 2 is what? Negative 2. F of negative 2 is 1, right? All right, f of 3. Is f of 3 positive or negative? Well, what goes when x is 3? Where's 3? Here. Where's my function? Here. So that means it's negative, right? F of 3. When x is 3, my function's down here. It's negative. Part D. Let me erase some of this out here. Is f of negative 1 positive or negative? Well, when x is negative 1, my function is up here. Negative 1, my function is here, so that means it is positive. So this one, f of 3 is negative. Down here, f of negative 1 is positive. For what values of x is the function equal to 0? Let me erase some of this stuff here. Where is my function equal to 0? Well, here it's equal to 0. Here it's equal to 0. Here it's equal to 0. For what values of x? So 0, 4, 6. My function is 0. What else? Where was I? For what values of x is your function less than 0? So again, my function is less than 0 right here. So from 0 up to 4, right? From 0 to 4. This piece here, my function is less than 0. And G, what is the domain of the function? Your x's, where do I go? From negative 4 to 6. So my domain, right, is what? Negative 4 up into positive 6. Okay, what is my range? How far down and up does it go? From negative 2 up to 3. Right? So my range, right, is when my y goes from, what did I say? Negative 2 to 3. Right? Those are your y's. What are the x-intercepts? Right here. We already said that. 0, 4, and 6. What is the y-intercepts? I made a mess here. Let me clear it out. My y-intercept, there's only one. Right here at 0. 0, 0. Right? How often does the line y equals negative 1, which is right around there, intersect the graph? 1, 2. That's this here. Okay? How often does the line x equals 1 intersect the graph? So where's the line? When x equals 1, that's a vertical line. So that only intersects the graph one time. Okay? M, for what value of x does the function equal 3? Where is my function 3? Right over here. So what value of x? 5. And the last one, for what value x does the function equal negative 2? When is my function negative 2? Right here, so that is 2. All right, so if there are any other ones in particular that you want me to do, let me know. Have a good day.